Dundigal. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about Register Transfer Language. So, in the Register Transfer Language, a digital computer system exhibits an interconnection of digital modules such as registers, decoders, arithmetic elements, and control logic. These digital modules are interconnected with some common data and control paths to form a complete digital system. And moreover, digital modules are best defined by the registers and the operations that are performed on the data stored in them. The operations performed on the data stored in registers are called micro operations. So, in the register transfer language, how we are transferring the one register to another register in the data form, in the form of data. So, the data always be stored in registers. Okay, these registers may be like 8-bit, 16-bit, 4-bit like this. Okay, so register transfer is nothing but we are transferring the data from one register to another register or one form to another form. So it is only with the digital computer system only it is possible. So a digital computer system exhibits interconnection of digital modules such as registers, decoders, arithmetic elements, and control logic. So these registers, we note that already decoders means encoder and decoder. So like this, and arithmetic elements. So arithmetic elements means arithmetic and logic, arithmetic operations. Add, sub, mul, division, like this. So these are the arithmetic elements, and control logic means arithmetic and control logic means AND gate, OR gate, NOT gate, like this. So these are the control logic. So all these modules are in the form of digital modules are applicable in digital computer system, and these digital modules are interconnected with some common data and control paths to form a complete digital system. And these digital modules are the best defined by the registers and the operations that are performed and the data stored in them. So these operations like add, sub, mul, division, and OR operation, NOT operation. So these are the arithmetic and these are the logic operations, control operations are performed in the data stored in the registers are called micro operations. So micro operations are nothing but a arithmetic and logic operations. So arithmetic and logic operations, these are the micro operations. So a micro operation is an elementary operation performed on the information stored in one or more registers. The result of the operation may replace the previous binary information of a register or may be transferred to another register. Examples of micro operations are shift, count, clear, and load. So the internal hardware organization of a digital computer is best defined by specifying the set of registers it contains and their function, the sequence of micro operations performed on the binary information stored in the registers, the control that initiates the sequence of micro operations. Okay, these are the register transfer language. First point, a micro operation is an elementary operation performed on the information stored in one or more registers. Suppose I am taking R1 register, R2, so on, Rn registers. So when we are performing, suppose R1 equal to A, R2 equal to B, suppose C equal to A plus B. That means what is means the addition operation of A, and A is one register, B is another register, C is another register. So in this C register, why I am using this? I am using the result value. So I am using C. So A equal to R1, B equal to R2. The resultant value is storing in R3. So how many registers I need for this operation? Total I need 3 registers. So suppose I am taking D equal to A plus B plus C. So like this operations I am taking R1, B equal to R2, C equal to R3, D equal to R4. So R4 equal to R1 plus R2 plus R3. So the elementary operations performed on the information stored in one or more registers. The result of the operation may replace the previous binary information of a register or may transfer to another register. So this resultant value will be stored in the previous binary information or it may be registered to be transferred in the another register. Examples of micro operations are shift, count, clear, and load. Shift means R1 to R2. R1 data is transferring to the R2, or R2 to R1. Or count. How count means, suppose I am taking n equal to 10. So it will start from n equal to 1, n equal to 2, n equal to 3. So count equal to 0, count equal to 1, count equal to 2, like this. Means how many number of iterations are there. It will be count. And clear means I am clearing all the program. And load means I am loading the values. Suppose C equal to A plus B. Load means A equal to some value. What is means A equal to 5, B equal to 6. So if I am giving the values of A equal to 5 and B equal to 6, this is called loading of values. Okay. C equal to A plus B means addition of two numbers. Those are stored in register C. So the set of registers, it contains and their function, the sequence of micro operations performed on the binary information stored in the registers, the control that initiates the sequence of micro operations. Okay. So any of the thing I am taking one register R1, it contains their function, the sequence of micro operations performed on the binary information stored in the register, the control that initiates the sequence of micro operations. Suppose I am taking R3 equal to R1 plus R2. That means C equal to A plus B. So I am giving A equal to 5 and B equal to 4. Example I am taking. So C equal to 5 plus 4 equal to C equal to 9. That means R3 equal to 9. The value of register R3 equal to 9. But in the register, how the values are storing, the input values are storing in the form of binary only. Okay. Always registers can store binary values only. Binary values only. So if I am taking R1 means, suppose I am taking it is a 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. So I am taking 100, 100, 10. Okay. So this A equal to 5 example. So this value will be stored in binary form. A equal to 5, it is in the form of binary only, it will accept. So B equal to 4, the binary value only accept. And the resultant value also we are storing in the binary form only. So the registers can store in the form of binary only, it will accept. So register transfer language, the symbolic notation used to describe the micro operation transferred among the registers is called the register transfer language. A register transfer language is a system for expressing in a symbolic form of the micro operations sequences among the registers of a digital module. For any function of the computer, the register transfer language can be used to describe the sequence of micro operations. And the register transfer languages are a symbolic language or a convenience tool for describing the internal organization of digital computer, and it can also be used to facilitate the design of process of digital system. Okay. So the symbolic notation used to describe the micro operation transferred among the registers are called the register transfer language. Okay. R1 to R2. How we are means the symbolic notation. So symbolic notation means, suppose I am using here shift. Shift R1 means the R1 value is shifting to the move R1 comma R2. Okay. So shift R1 means the register of R1 values are have to shift to another register. So I have to shift. How it is possible means I am using, it is one program. Okay. So it is a symbolic notation to use it to describe the micro operation transferred among the registers are called the register transfer language. Okay. I am giving some program to I am giving some instructions. Okay, I am giving some instruction to transfer the registers or operation. For the performing of operations through the instructions only it is possible. And a register language system for expressing in symbolic form of the micro operation sequencing among the registers of a digital module. For any function of the computer, the register transfer language can be used to describe the sequence of micro operations. Okay, what are the binary operations or in the register? We have to use the programming in the notation the register transfer language can be used to describe the sequences of in microoperations. And a symbolic language. Register transfer language is a symbolic language. The expressions are in notation is a symbolic notation, and a convenient tool for describing the internal organization of a digital computers, and it can also be used to facilitate the design process of digital system. Okay, it is for designing process of digital system also we are using the register transfer language. And the designation of registers. Registers are designated by capital letters, sometimes followed by numbers. Example A R R13 IR like this. So often the names indicate function. MAR memory address register, PC program counter, IR instruction register. And the registers and their contents can be viewed and represented in various ways. A register can be viewed as a single entity. Register may also be represented showing the bits of data they contain. So designation of registers. How we are using the registers, how we are capitalizing, or how we are symbolic the notation of the registers. Means here I am taking, suppose A is nothing but it is one type of register only. R13 it is also one register. IR is also instruction register. So in the previously I told, suppose I am taking C equal to A plus B. So here C is nothing but a R3, A is nothing but a R1, B is nothing but a R2. So R1 is one register which is stored the values of A. R2 is also one register which are stored the values of B, and resultant value is stored in C, but C belongs to R3. So the notations are in the form of registers like this one, or in the form of ABC, or in the form of instruction registers. Instruction register also we know that add, mul, div like this. Add A comma B. Add A comma B means the A comma B values, addition of A comma B, the resultant value will be stored in, the resultant value is nothing but a IAR instruction register. Add is one register, multiplication is one register, division is also one register. Okay, so the resultant values stored in one register. So that is I am taking as a IR instruction register, or program counter PC. Already we know that suppose I am taking A equal to 10. So A is starting from A equal to 0, A equal to 1. Suppose I am taking A less than B. Suppose here how A less than B means, if I am taking A equal to 0, B equal to 0, A equal to 1, B equal to 0, A equal to 2, B equal to 0, like this. I am taking different values of A and different values of B. So these how we are giving the inputs. A equal to 0, 1, 2, 3, 4, 5, 6, 7, 9 or 10 like this. Okay. Program counter will count how many inputs you are given to A, how many inputs you are given to B, how many total values you are given. Program counter will count PC equal to 0, or PC plus 1, PC plus 2 like this. Okay. Program counter equal to 0, program counter PC plus 1, PC plus 2 like this. And memory address register means in the particular address, suppose in a memory, these are the addresses. What is address means 101101. Suppose I am taking. So in this address, that the register values are 110, 110, 11. So in this 1000, 1000, 11. Okay. See here also 10, 10, 10, 10. So in the register, in the particular memory, what is the address? Here address is a, this address is 10, this address is 11, this address is 01. So in the particular address, what is the data? In the set of memory, in the particular address, what is the data in the particular address? So here I am taking one particular address. What is address means? 10 is one particular address. In that address, what is the data is there? The data is a 110, 110, 11. The data is there, but where it is stored? So it is stored in a M of AR, or memory of address register. So in this address, the data is there. What is the data? M of DR. What is the data means? M of DR. Okay. Memory data register. So memory address register means in the particular address. In the particular address, the data is there. What is the data means? MDR. Memory data register. So M of AR or MAR, M of DR or MDR. So these are the specifying of addresses or specifying of registers or names indicated as a registers or designation of registers. And a register can be viewed as a single entity. The register may also be represented showing the bits of data they contain. Another one is a register transfer. In symbolic notation, it is used to describe the micro operations transferred among registers. It is a kind of intermediate representation instruction register that is very close to assembly language, such as that which is used to a compiler. The term register transfer can be performed micro operations and transfer the result of operations to the same or the other registers. Okay, when I'm taking the RT means register transfer, it is already we know that it is a symbolic notation. It is a symbolic notation of the register transfer. Register transfer means we are transferring the data from one register to another register or one memory to the another memory through the registers. And to describe the micro operations, already we know that what are the micro operations? Shift, rotate, and clear. Okay, shift, rotate, clear, and call, like this. Okay, so these are the micro operations transferring among registers in a kind of intermediate representation of instruction register and close to assembly language, such as that which is used in a compiler. Okay, any of that one we are taking as an assembly language is converting to the machine language. The term register transfer can perform micro operations and transfer the result of operations in the same of other registers. So micro operations are executed on the data stored in registers are called micro operations. They are detailed low-level instructions used in some designation to implement complex machine instructions. And register transfer is nothing but the information transformed from one register to another register is represented in symbolic form of replacement operations are called register transfer. So in the micro operations, suppose I'm taking shift operation or I'm taking clear operation. Example, I'm taking these operations. Okay, for this I need a register and I need a data to stored in register is called micro operations. Okay, which I need a register, which I need data to perform the shift operation or clear operation or etc. That is called micro operations. Okay, these are called micro operations. And register transfer means we are transferring the data of registers from one form to another. To transfer of one register to another register is represented in symbolic form. To replacement of operations called register transfer. And replacement operation, that means R2 less than or equal to R1 acts as a replacement operation. This statement defines the transfer of content of register R1 into R2 register. R2 to R1 means the content of register R1 into R2. The R1 data is stored in R2. R2 data is stored in R1. That is called register transfer or replacement operation. Replacement means the complete data of R1 is converting to the R2 or the complete data of R2 is transferring to the R1. So there are various ways to represent registers in block diagram form. The general ways of representing a register in by the name of register enclosed in a rectangular box as shown in R1. I am taking R1 of A. Register in numbered in a sequence of 0 to n-1 as shown in B. So if I am taking various ways to represent in a register, so I will take in the form of A, I will take in the form of B or C or R1, R2, R3, like this I am taking. So already we took like this A, R13, IR, or I will taking as an instruction register IR. Okay, IR. So the general way of representing register in the name of register enclosed is a rectangular box. I'm taking as R1. Okay, R1. Maybe I'm taking as R1 as A. In place of R1, we will take as A also. Okay, and also IR. So whichever whatever maybe will take that is correct. But here I'm taking R1. I'm taking one example of R1. Okay, register numbered in sequence of 0 to n-1. So this R1 is it 8-bit or 16-bit? How can I know? As a user, how can I know? So I will be represented as 7, 6, 5, 4, 3, 2, 1, 0. How many are there? 8. So it is a 8-bit. Okay, it is a 8 bit. So I'm representing as indirectly my register is a 8 bit. I'm showing as a 0 to 7. Okay, my register is R1 with 8 bit. But here I have the R1 register, but what is the size I don't know. But we have to identify. But here we are clearly representing 0 to 7 means 7 bit of register, that is R1. Here R1 register I am representing. Okay, like this. So these are the various ways to representing the register. And here another one is a numbering of bits in registers can be marked on the top of the box as shown. PC means program counter. So here 0 to 15, that means it is a 16 bit. It is a 16 bit. The program counter is a PC equal to 0, PC plus 1, PC plus 2, like this, PC plus 15. Program counter equal to 15 means it is a 16 bit. Okay, it is a 16 bit program counter. The register is a program counter with which are showing showing is a 0 to 15, and a 16 bit register program counter is divided into two parts. 0 to 7 are assigned with lower bytes of 16 bit address, and bits 8 to 15 are assigned with higher bytes of 16 bit address. Okay, so this 0 to 15 we are taking as a 0 to 7 and 8 to 15. Here also 0 to 7 is a lower order, 8 to 15 I'm taking as a higher order. Okay, so the 16 bit register of a program counter dividing into two parts, that is a L and H, lower order and higher order. Lower order from 0 to 7, higher order from 8 to 15. With the 16 bit address with 8 to 15 are assigned with higher bytes of 16 bit address is shown in D. Okay, so program counter of lower order, program counter of higher order. Lower order means 0 to 7, higher order means 8 to 15. It is also one type of register representing, okay, or various ways to representing the registers. Okay, these are some basic notations of register transfer language. These are letters and numbers. Okay, MAR means memory address register. Memory address register of R1 and R2. This belongs to address, where it is showing as a address of the memory or address of the registers, and here it is showing as a the symbol showing as a denotes of a part of register. Already we know that symbols are nothing but a register transfer language. So symbols are nothing but a register transfer language. Okay, this symbol as denotes the part of register, that is from R1 is 8 bit or 0 to 7. Okay, it is a R1 register which is 8 bit, representing 8 bit, that is from 0 to 7. And this is represents the denotes the transfer of information from R2 to R1, and specify the two micro operations of register transfer, R1 to R2, R2 to R1. And this symbol is represents the condition operation. Condition means if condition, like this. If P equal to 1, then R2 less than R1. If P equal to not 1 means the condition is not satisfied. Okay, if not satisfied, it is also not satisfied. The naming of the symbol is nothing but denotes another name of already existing register, that is RE equal to R1. Okay, and another is a control functions. Often actions needed to only occur if a set condition is true. This is similar to an if statement in programming language. In digital systems, this is often done via control signal called the control function, and the signal is 1, the action takes place, and this is represented as R2 to R1, which means P equal to 1, the load of content of register R1 into R2, that is P equal to 1 or R2 to R1. Here notations are R2 to R1 or R1 to R2. What is the condition means? Here it is when P equal to 1 only, the condition is satisfied. And hardware implementation of controlled transfer, that is from R1 to R2. Implementation of controlled transfer from R1 to R2. So is it any condition means if P equal to 1, if condition is there, then we have to satisfy this condition. Okay, here R1 is not equal to R2. Okay, when I am applying the clock pulse R1 to R2, it is a control circuit. It is a loading function, means loading means we are giving some values to the register. Okay, loading means activation. The values, we are giving some values to the register, and the same clock controls of the circuit that generates the control function and the destination register. So the registers can assume to use positive edge triggered flip flops. Okay, so flip flop is nothing but a one bit of binary can store one bit of binary can store, like it is one flip flop 1, it is another flip flop is 0. Okay, it is a flip flop with value equal to 1, it is a flip flop with a value equal to 0. Okay, only one bit of memory will be stored, that is the flip flop. And simultaneous operations, the two or more operations are can be occurred simultaneously, they are separated with commas. Okay, here R5 to R3. Here MAR tends to IR, means instruction register, the values are storing to the memory address register. Okay, the instruction register values means what are the stored values of data in the instruction register, we are transferring to the memory address register. That means IR equal to 0. Now IR equal to clear, that means no data in IR. So the control function p equal to 1, the load of content R5 into R3. So if I am taking a p equal to 1, then only R5 into R3. Okay, the load the content of register IR to MAR. Okay, so when this condition will satisfy, then only R3 to R5. Okay, then only the condition will be satisfied, that is IR to MAR. And the connecting registers are in a digital system with many registers. It is impractical to have data and control lines to directly allow each register to be loaded with the content of every possible other register. To complementary connected to n registers, that is n of n minus 1 lines. Okay, n of n line means 8 bit I am taking means 8 of 8 minus 1 lines. Cost is high. This is not a realistic approach to use in a larger digital system, and instead of take a different approach, have one centralized circuits of data transfer in the bus, have control circuits to select which registers in source, which is the destination. Okay, connecting registers means we are connecting from one register to another register. Okay, I am taking connecting of R1 to R2 means the values of R1 we are transferring to R2. Why? Because we are transferring the registers to transfer the data. Okay, set of circuits for data transfer from one register to another through the bus, and the control circuit to register the source to destination. Okay, control circuit is nothing but a source to destination. The data is properly converting or not. Okay, register transfer operations are performed in the data stored in the register are referred to as register transfer operations. And the simple example is simple transfer means R2 to R1, R1 are copied to R2, R1 are copied to R2. Okay, it is a simple operation. And the condition means R2 less than or equal to R1, R2 less than or equal to R1. It is a condition, means if we have the condition, then only it is go. If condition is not satisfied means it will be stop, the transfer will be stop. Okay, what is a condition means if p equal to 1, then only it will be transfer. If p equal to 0 means it will be not transferring the data. And simultaneous operations means if two or more operations are occur simultaneously, then they are separated with comma. Two or more operations are performed, then only simultaneous operations will be there. Okay, so here I am taking control operation with p equal to 1, p equal to 0 is there. What is the operation? P equal to 1, what is the operation? Means two or more operations are there. P equal to 0 means one operation, p equal to 1 means another operation. So here how many operations means two operations are performed. Okay, and if the p equal to 1, the load of content R1 to R2, and the clock load is R2 into R1. Okay, so p equal to 1 means R1 to R2, and the clock pulse is R2 to R1. So R1 to R2 is one performance, R2 to R1 is another performance. Okay, these are the references. Okay, we have discussed today register transfer language. So in the register transfer language, in the digital computer system only, where interconnection of digital modules, to the register, decoder, arithmetic operations, and control logic. These are the operations are performed with the digital transfer language, and the micro operations are performed like shift, count, and clear, and load operations are performed with the micro operations. And the set of registers it contain in their function, the sequence of micro operations performed in the binary informed to store in the register, the control that initiates the sequence of micro operations. And register transfer means the symbolic notation used to describe the micro operation transfer among the registers is called a register transfer language. And the register transfer language is a system to expressing symbolic form of micro operations. Means symbolic language we are describing, and for the designing process also the digital systems can be using for register transfer language. And the designation of register means what is a designation means MAR, PCIR. MAR means memory address register, memory data register. For address specification I'm taking MAR, for data specification I'm taking MDR, and for the programming count, number of count, how many iterations are there, we are taking as a program counter. And instruction register means we are following add, multiple, division. These are the instructions following by the register, and these are the instruction registers. Okay, and register transfer language is nothing but we are taking as an intermediate representation of IARE. And the micro operations means we are performing the shift operation, shift operation, count operation, clear, and load operations are performing. These are called micro operations. And register transfer means we are transferring from one register of data into the another register, R1 to R2 or R2 to R1, like this. And there are the various type of representations. Suppose I am taking it is a register R1. Here I am taking 0 to 7 means it is a 8-bit of register. Symbolically I am showing us it is a 8-bit of register. Here I am taking 16-bit. How can I know means 0 to 15? That means 16-bit. That is a program counter representation. If I want to divide the lower order and higher order means 16-bit I am dividing as a 8-bit and 8-bit means 0 to 7 and 8 to 15. So these 16 bits are dividing as a 8-bit and 8-bit. These are the symbolic register transfer language notations. MAR of R1 R2 and notations of R1 with 8-bit, and R2 to R1 data transfer, R1 to R2 data transfer, condition operations. If P equal to 1 only, if P equal to 1 satisfies, then the data of R1 register is copied to R2 or R2 to R1, like this. And the control functions means we are controlling the register transferring of data from one register to another register. Means control function means if I am taking P equal to 1, then only we have to transfer the data. If P equal to 0 means we can't transfer the data. That means control means condition operations. And hardware implementation means we are loading the function. If P equal to 1, then only it is loading. If P equal to 0, we can't load the values from R1 to R2. It is a simultaneous operations means simultaneously we are taking means R5 to R3 is one operation is going on, IR to MAR is also going on. So simultaneously means parallelly we are doing the operation. Okay, not a one by one serial. We are parallelly doing means simultaneous operations are performing. Connecting registers means we are connecting the two registers through the bus, and it is a simple data transfer R2 to R1. And conditional operation means when P equal to 1, then only the data can be transferred. Simultaneous operations means simultaneously number of operations can be performed or number of iterations can be performed. That is the simultaneous operations. Okay, it is about the register transfer language. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.